Okay, now we're going to talk about finding function inverses. So if you are given f of x, when you find the inverse, this is the inverse notation, f to the raised -1 of x. Sometimes you can write it as y to the -1, and I'll show you when you do that. So how you find, if you're given an original function, these are the 4 steps. Rewrite the original function instead of f of x, rewrite it as y is equal instead of f of x is equal. And then swap the x's and the i's, nothing else. Don't swap the negative signs, don't swap anything else. So like if there was a y over here and inside here -3x, you don't put the -3x over here when you swap. This just becomes x. This becomes -3y. So you're just swapping the x's and the y's. All right, third step. Once you get the x and y's swapped, then go ahead and solve for y like you would normally do. And then once y is by itself, rewrite it as either y to the raised -1 or f to the raised -1 of x. All right, let's get started. First thing you're going to do is you're going to determine if the given functions are inverses. So I'm going to take this original. The first step is to rewrite it as y is equal. So I did that. The second step is to swap the x's and the y's. And so I think what I have been doing is you swap the x's and the y's just to make that visible. All right, then you get the y by itself. In this case, we're just going to add 1 on both sides. And now that the y is by itself, I'm going to rewrite it as y to the raised -1 is equal to x plus 1, or, oh, I didn't do that. Well, in this case, you're just checking to see if g of x, so in this case, the inverse of the g function is g to the raised -1 of x, and that matches the f of x, so yes, they are inverses. All right, so let's come over here. So now we're starting off with this x to the 5th plus 1. Well, first of all, what's the inverse of taking something to the 5th power? Taking the 5th root. Is the cube root the inverse of the 5th root? No, but I'm still going to show you the process. We're going to rewrite f of x to y. We're going to swap the x's and the y's. I'm going to subtract 1, subtract 1. When I do that, I'm going to take the 5th root of both, which is what I did right there. So the x subtract 1, then I took the 5th root, and the 5th root of something to the 5th power, those cancel, leaving just the y. So notice the inverse to f, so f to the raised -1 of x is the 5th root of the expression x subtract 1. Is that the same as this? No. But you could have actually saved the time. You could just circle those and just tell me a cube root is not the inverse of a 5th root. All right? Now, all right, now we're going to find the inverse of each. So we're going to take our steps. We're going to rewrite f of x as y is equal. So that's all I did here. Now we're going to swap the x's and the y's. And then notice that y is in the numerator. To get rid of that dividing 3, I multiply both sides by 3. And once I do that, you have -y plus 4. So I'm going to subtract a 4 both sides. Let's see if I did that in the next step. So then I would subtract 4. But look at what this has. This has a negative. That's a -1y. So you're either going to multiply everything by -1 or you're going to divide. All that means is when you divide this by -1, that sign changes. So that sign's going to change and that sign's going to change. So now that you have y by itself, you're going to rewrite it as y to the raised -1, or f to the raised -1 of x is -3x plus 4. And that's how this right here is the inverse. And then notice, here, let me cover a bunch of stuff up. So you're just looking at this. Notice the original. The original function is dividing 3. There's that. If you were to separate those fractions, that would say -1x divide 3. Well, look at what this says. -3x, -3 times x. So those two things are inverted. And oddly enough, that's still a plus 4 because, well, I'm not going to go to that. So you have to be careful. That won't always necessarily turn to subtract 4. And my guess is because, not my guess is, when that lead coefficient of x, that changes things a bit. All right, so now I'm going to go on to this next one. We have something to the 5th power. Well, my guess is the inverse of taking something to the 5th power is taking something to the 5th root. Step 1, rewrite it as y is equal. Step 2, swap the x's and y's. To undo something to the 5th power is take the 5th root and then the 5th power and the root cancel. Just like that. And then notice that has a subtract 3. We're going to add 3. When we add 3, it's on the outside of that parentheses or of that radical sign. And now we have y by itself. And so you can rewrite it as y to the raised -1 or, whoops, f to the raised -1 of x is equal to the 5th root of x on the outside of the radical plus 3. All right, one more. So we're going to rewrite this as y equals. That's the first step. We're going to swap the x's and the y's. And notice we have a fraction right here. But we also have a subtract 1 that's not part of the fraction. So you're going to add 1 to both sides. That's going to be your first step. See if I did that there. Yep. And then notice we have a y in the denominator. We don't want the y there. We have to solve for y. Think about this expression over here as an invisible 1. And now that underneath, now that we have a fraction equal to a fraction, we can flip both sides. And now y is in the numerator. To get rid of that dividing 3, we multiply both sides by 3. 3 times 1 is 3. And then you're going to have y plus 1. We're going to subtract 1. When you subtract 1, it will not be part of the fraction. You have to do it separate from that fraction. Just like that. Y is by itself. So now we can rewrite it either as y to the raised -1, since this is g of x, g to the raised -1 of x. And then there's your function. And then one last thing. It says find the inverse and then graph. Well, this original one, see how that is 2 things over 2? I'm going to break this down into 2 separate fractions. Well, 6 divided 2 is 3. That's how far we go up and down because that's a positive 3 on the outside of the radical. And then that invisible 1 divided by 2 is just -1/2 times the cube root of 4x. And I've identified the A, B, and D. And normally, the D would be over here. It would be plus 3. Now look at that says negative. So we know this original graph is going to be flipped. Normally a cube root looks like this. Well, because of that negative sign, it will look like this. And where is it going to touch the y-axis? Right up there at 3. I already have that drawn, but I don't want to show you it yet because now we have to find the inverse function. So we're going to rewrite this as y is equal, and we're going to take that original function. We're going to swap the x's and the y's, and now look at, there is a divide 2, so we're going to multiply both sides. Then there's this positive 6 on the outside. We're going to subtract 6. And let's see if I did that. Yeah, there we go. Now look at, this is cubed. That's an equal sign right there. That is something to the cube root. So we're going to cube both sides. And when we do that, now we have 4y. Well, then you're just going to divide everything by 4. That's what I have right there. I cubed both sides, which left me 4y. Then I divided both sides by 4, leaving y. And now you can rewrite it g to the raised -1. And now look at, divide 4 means the same thing as 1/4 being multiplied. Well, that's going to be the a. That means it's a vertical compression. It's going to be flatter. So think about slope as up 1 over 4. It's going to be a much wider graph. And now look at, what would zero out that -6? A positive 6. 2 times 3 is positive 6. So we're going to slide. Remember, now we have a cubic, and a cubic's graph looks like this. But we're going to slide it over, and we're going to make it a lot wider. So notice what happens. Let me cover all this stuff up. Whoops, not by doing that. So see this blue graph right here? This is the original, g of x, and now this is the cubic. This was the f of x, or the g, the inverse. And then how you know functions are inverses graphically? If through the origin, if you draw a dotted line and across that slanted asymptote, these look symmetrical. So if you folded that graph on that diagonal, those two graphs would probably lay on top of each other if I would have drawn them really well. We're going to pretend that I drew them really well. All right, that is it. So we talked about Pascal's triangle. Well, I shouldn't add that here in case you don't see. And then inverse functions.